Okay, so we know that Euler cannot stay in the land of algebra. He must go up the mountain and find how to do this. And he ascends the mountain called Transcendental Mountain. And I can't spell transcendental. I'm going to have to get a book to look up and find out how to spell transcendental. Somebody says, Mr. Evans, we'll look it up on the computer for you. Transcendental. I got it right here. Oh, yeah. I wasn't going to spell it wrong. Transcendental. Transcendental Mountain. It's a cool name. Transcendental Mountain. Transcendental Mountain comes from a concept that you learned about in English and history, hopefully. Y'all talked about a form of philosophy called Transcendentalism. Yeah. That's where the word comes from. They stole it from us. Math used it first, and then they stole it. Okay? You can tell your English teachers that. Don't get me in too much trouble. But transcendental. What did transcendentalists think? Or what was the basic explanation of transcendentalism?
The importance of like nature and being in nature, not like having too much like worldly like possessions or ties.
Okay. And what did they say would happen if you were in nature? What would you develop about nature? Enlightenment, okay. I like that. Yeah, enlightenment. You would learn maybe some governing principles, or you would learn to step beyond what you could actually just see right there, okay. You would transcend what you were looking at. Well, let me give you my example of transcendentalism, and this is probably wrong because I'm not a philosophy major, don't know a lot of philosophy. But I do know that I want y'all to think about when I drop this pen. You see what? You see it fall, which is good. You do see it fall, but what do you instantly think about when it starts falling? You think about it's going to make a noise when it hits the ground. And do you ever think about why it falls? Gravity, yeah, gravity. But do you ever actually see the gravity? No. Transcend. You look at the information that's out there, and then from that information you can come up with the laws and the explanations for why it's happening. But you can't see the gravity. Does that make sense? Yeah. There's not an algebraic function that works, but there may be a function that we're going to create that we know we made to work. Because we know there should be an inverse, right? And we even know the points that are on the inverse. So we need a function that will make that happen. We're transcending the algebra. We know the algebra works for a lot of stuff, but it won't work for this. So we create what's called transcendental functions. And transcendental functions, you've already done some in geometry, you just didn't know it. But transcendental functions are functions that we need. They have to work. They have to fit all the mathematical world, but they're not algebra. And for this one, he called this one log base 2 of x. And that was a transcendental function for 2dx. He called this one log base, what do you call it? Log base 5. Yeah. Now you even know why when y'all look at those logs in your science class or your other classes, they have all those different bases. Because what they're doing is when they tell you the base, they are telling you which exponential function that it is the inverse of. In other words, log base 10 is the inverse of 10 to the x. log base 5 is the inverse of 5 to the x. Now, we're not saying we can work it out. Yeah, we just know it's true. We know log base 5 of 1 is 0. We know log base 5 of 125 is 3. Log base 2 of 1 is 0. Log base 2 of 2 is 1. Log base 2 of 32 is what? 5. But somebody says, well, how'd you work that out? I didn't. I know it happens because there's the original function, and I know this has to be the what? Has to be the inverse. That's right. That has to be the inverse. So when Euler was on the mountain, the Transcendental Mountain, he got very lucky. Because on the Transcendental Mountain, there was a burning math book that never burned up, but it continued to burn. And out of the math book came the laws of the Transcendental right here. And they were written on platinum. They were written on platinum sheets. And it was engraved into the platinum sheets. And there were 7 laws. Okay? And here's the 7 laws that were on the sheets. Law 1. These are the laws that were on the platinum sheet. Law number 1. Logarithm laws. Law number 1 said that no matter what the base was, if you were taking the log of 1, no matter what the base was, you would always get 0. Well, I didn't put a bunch up here, but look what happens. What's log base 2 of 1? What's log base 5 of 1? What's log base 10 of 1? 0. So log of any base, as long as you're doing it to 1, is always going to give you a what? 0. That was the first law. And I can't prove the law to you in the sense that I can do a proof or anything, but I can at least show you this chart, and I think everybody agrees. And think about it. Any exponent raised to the 0 is always going to equal what? 1. So if we're going to do the reverse, that 1's got to turn back into what? 0. If I take a million to the 0, it equals 1. So if I do the inverse, the 1's got to turn back into what? 0. Is that okay? So while you can explain the law and you can see that the law is there, it's a law. Okay? And then the bush burned a little brighter. And law 2 was etched onto the platinum stone. Log base b of the number b will always equal 1. Okay? In other words, log base 2 of 2 equals what? 1. Log base 5 of 5 equals 1. Log base 10 of 10 equals 1. Notice I'm just having to show you that it works, but I can't algebraically make it happen. Okay? I can't sit there and go, oh, divide by a number, multiply by. I'm just telling you, this is how it has to be. Because this is not an algebra function, this is a what? Transcendental function. Got to work this way. Which is a little bit weird for y'all. I mean, I know it's kind of a different idea that all of a sudden we've got a rule in math that I'm just telling you has to work that way. I know, that's a little strange. And that's the reason y'all get messed up with logarithms, is because y'all don't want to admit they just have to work that way. But they were made to do a certain thing. They were made to be the inverse of exponential functions. And since they were made to be the inverse of exponential functions, they're not an algebraic form. They're a form that we have definitions for, we have laws for. Okay, see the difference? Yeah, you're making a big jump in thinking skills here. Part 3. This one's pretty cool. Log base b of b raised to any power will equal that power. This one I'm going to have to do a little math work with to make it look good, make it pretty, and make it work. But I'll do that for you. Let's go over here. I'm going to erase the 10 stuff so I got room to work. And we'll just use the 2s and the 5s to be happy. All right. Now, I'm going to look at log base 2 of 2 cubed. I'm telling you that has to equal 3, right? That's what my rules say, right? Okay, well, does everybody agree that that's really log base 2 of 8? What's 2 cubed equal? 8. Let's go over here and see if we can find that. Oh, there it is. Log base 2 of 8 is 3. Okay, now, let's say I had log base 5 of 25. That's not my rule, is it? Because it says that the base and this number here have to be the what? Have to be equal, right? But what do you know about 20? Well, the answer tells you it has to be what? 2. Right? We know it has to be 2, but look what you can do. And now you know why on the ACT test they have a problem. It's like log base 2 of 32, and you get to pick the answer, and it's 5. Log base 2 of 32 is 5. Do you have to memorize this? No. You just need to know what? That. Because if you have log base 2 of 32, that's the same thing as log base 2 of 2 to the 5th. And then our rule tells us that's going to always equal what? 5. And I just showed you that it really works by using some of the ones that we have over here. Is that a good one? So far, so good. All right. Now, there's a rule that rule number 4. If I have log base b, and I have a number here, but it doesn't equal it, and I've got a power up here. Okay? Got the power up here, but this number and this number aren't equal. Up here they are equal, right? So I'm about to answer the question, what do you do if they're not equal? Okay? You can bring the power to the front of the log. Okay? That one may be a little bit harder for me to explain. All right? But I'm going to try. I think I can do it. Y'all ready for the explanation of why that works, where you can bring the power to the front? Okay? Is that all right? See that 5 right there? I'm going to bring it to the front. 5 times log base 2 of 2. What does log base 2 of 2 have to equal? What's 1 times 5 equal? Isn't that the same thing I told you would get up here? Okay. Let's see if it'll work on this. Well, if you bring the 2 to the front here, right, you would have 2 log base 5 of 5. That'd be 2 times 1, and it's still what? 2. So it works.
So where are you getting the 1 from?
What's log base 5 of 5?
1.
There you go. See, I'm using that rule. So really, this rule relies on you needing to know this rule works, and it gives you a chance to see that if you use this rule and this rule together, you'll get the same thing as number 3. All right? Yeah, it'll give you the same thing as number 3 if you use them together. But this one's going to be handy later on. All right? Somebody says you're having trouble remembering all the rules. Yeah, because I'm trying to put them in a certain order, and I never do that very well. I always forget the 5th rule. Okay? Now, that's the first 4. Now, Euler was on the mountain a long time. They were all written in platinum. They were written on a platinum stone. And they gave him 4. Now, I cannot go to 5, 6, and 7 yet because I'm running out of energy, and also we're running out of time. Also, there is an 8th rule, but it didn't come off the mountain. Euler, when he came back off the mountain, only brought 7 rules. And then his disciples added an 8th rule. All right? And the 8th rule is really a combination of other rules, but it just makes it easier for you to work some things. But it's not one of the original laws that came down with Euler. I didn't call him by the wrong name just then, did I? Yeah, the original laws that came off the mountain with Euler, there's 7 of them, the Transcendental Mountain. I'm waiting for somebody to make a comment about my story, but nobody has, so I'm going to turn the computer off.